Bismillahirrahmanirrahim. Assalamu dear students. My name is Dr. Tanveer Akbar Kiani. I did my PhD from France. My area of research is computational fluid dynamics. I am working as an assistant professor at Comsats Institute of Information Technology, Islamabad. Now we talk about the calculus and analytical geometry. This course I will teach you in next 32 lectures. So first of all, I would like to introduce you the books which I will follow. The core textbook which I will follow, that is Calculus, written by Howard Anton, the 8th edition, that is easily available in the market. You can purchase it in just 300 rupees. And the second book that is will be used as a reference book is the Calculus by Skorsky, Olenek and Depends. And this is the 6th edition of this book, and this book is also available in the market. But I will the first lecture I prepared from this book, because the contents of first lecture are not available in the book in the Calculus by Howard Anton. The course outline consists of inequalities, functions, shifting graphs, limits of functions, continuity, derivative of function, application of derivatives, integration, indefinite integrals, definite integrals, application of integral, area, arc length, transcendental functions, L'Hopital rule, techniques of integration, improper integrals, infinite series, limit of sequences of numbers, convergence and divergence tests, alternating series test, absolute and conditional convergence, power series, Taylor series and Maclaurin series, convergence of Taylor series, error estimation and application of power series. So our course consists of 32 lectures, and in between the lectures I will give you assignments and quizzes. So there will be 4 quizzes through in this course, 4 quizzes and 4 assignments, and there will be 2 sessions, session 1 and session 2, and the end will be a terminal. So marks distribution will be as follows. So 25% consists of the quizzes and assignments, and 10% session 1, 15% session 2, and the terminal consists of 50% marks. So in this way it will make up 100 marks. Please follow all the lectures regularly, and at the end of lectures you must read the lectures at home also, so that you can easily perform good in the quizzes and in the assignments. And now what is the calculus? Calculus is branch of mathematics which deals with functions, limits of functions, continuity, derivatives, integration and infinite series. Calculus has numerous applications in physics and engineering. Calculus played a fundamental role in the development of modern science. If you look at this book, if you look at the figure on the left side, so this boy is solving some engineering problem, and you can see that he is solving some equations, that is a differential equation. And in the right figure, so we are going to make a box from the cardboard. So by cutting the ends of the cardboard, so that we can get a box with maximum volume. So that can be made by using the mathematics, and we will see in the coming lectures you will see that how can we apply the mathematics by making a box like this. Now it says students of calculus, he is asking from his doctor, he is at this time patient, It's a reoccurring nightmare, doctor. I dream I am in this class where calculus is the easy part. Now the first day of class is Shua. The student is coming into the class saying, I am so excited for calculus. And the students who are sitting this is saying, I really hope he doesn't sit by me. I don't know how many of you are so excited. I will see in the later on through exams that you are excited or no. At the end of 32 lectures, I hope everyone will be a captain of the calculus. And we'll start from the first topic, the real numbers. All concepts in calculus are based on properties of the set of R of real numbers. There is one-to-one correspondence between R and the points of a coordinate line or real line. So if you look at this figure, this is a real line, and the real R is this R represents the real number systems. So on the real line, the numbers are represented. If you look at this one, there is a 0 in between, and on the right side of the 0, the numbers are positive, and on the left side of 0, the numbers are negative. And in between these numbers, there are other numbers that like between 1 and 2, there is a one number under root 2, and between 2 and 3, there is a number e, and after 3, there is a number pi. You know the value of pi is 3.1416. So there are many infinite numbers which lie between the integers like 1, 2. So if you look at this figure, this diagram actually that gives us a complete pictures of the numbers. Actually the numbers start from the complex numbers. The complex numbers are the bigger one, and then these complex numbers contains the real numbers, and the real number consists of rational and irrational numbers. The rational numbers are of the form 2 by 3, 7 by 5, like 23 by 1, 0.19, minus 5 by 2, like that. These are the rational numbers. And the integers, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, so on. These are the integers. And the natural numbers are 1, 2, 3, 4, 5, so on. These are the natural numbers. If you look at this diagram, so natural numbers are the subset of integers, and the integers are the subset of rational numbers, and the rational numbers are the subset of real numbers, and the real numbers are the subset of complex numbers. Mean natural numbers, they are contained in integers, and integers contained in rational numbers. Rational numbers are contained in real numbers, and the real numbers contained in complex numbers. Inequality. If A and B are real numbers, then A is greater than B if A minus B is positive. This is okay. This is a symbol for greater than. This symbol is for greater than. A is greater than B if A minus B is positive. And on the other hand, A is less than B if A minus B is negative. A is less than B if A minus B. So this is a symbol for less than. A is less than if A minus B is negative. So these are the inequalities. So A greater than B, this is the one inequality. A less than B is the other inequality. So there are some other inequalities. So we can write in symbolically that, for example, if write a less or equal to b, a less or equal to b, so it means that, what does it mean? It means a is less than b or a is equal to b. So we read this as, हम इसको ऐसे रीड करेंगे that a is less or equal to b. So we read in this way, a is less than or equal to b. Similarly, a greater or equal to b, this implies, हम कैसे पढ़ेंगे, a greater than b or a is equal to b. So we read in this way, a is greater than or equal to b. So this is also an inequality. So for example, five is greater than 3, minus 7 less than minus 2. Remember that minus 2 is greater than minus 7. Minus 3 square greater than 0. A square greater or equal to 0 for any real number A. A is any real number. A can be negative, positive or 0. So a square, that will take the square, it will be greater or equal to 0. So when it will be 0, when a is equal to 0, then it will be equal to 0, and in all other cases it will be greater than 0. And now we look at some properties of the inequalities. Number 1, if a greater than b and b greater than c, then a greater than c. If a greater than b and b greater than c, then a greater than c. This is called the transitive property. Number 2, if a greater than b, then a plus c greater than b plus c. So if a greater than b, then a plus c greater than b plus c, means if we add some number, any number on both sides, then inequality will not change. Let's see this with the help of example. So for example, what we saw before, 5 is greater than 3. So add, let's say minus 2, adding minus 2 on both sides. So 5 minus 2 will be 3 greater than, and 3 minus 2 1. So if you look at this, the inequality is not changed. So it means if we add any number, if you add positive also, so it will give the same result. The inequality will not change. Same result means the inequality will not change. So property number 3, if a greater than b then A minus C greater than B minus C. So if we subtract some number, then also the inequality will not change. So what we did before in the above example, so actually we added minus 2, it means we actually subtracted minus 2 from the numbers. So it doesn't matter C is negative or positive, so the inequality will remain the same. And the property number 4, if A greater than B and C is a positive, then AC greater than BC. So if C is a positive number and if you multiply both sides by this number, then the inequality will not change. See the example again, the same, 5 greater than 3. So take any number, C positive, so take any number, let we take 2. So multiplying both sides by 2, 5 into 2, 3 into 2. So 5 into 2 will become 10 greater than 6. So this is true. So 10 is greater than 6. So we have seen that multiplying with positive number, the inequality does not change. Number 5, if A greater than B and C is negative, C is negative, then AC is less than BC. So if C is negative, then inequality will change. So take the same example, 5 is greater than 3, will multiply by, now take minus 2, C take minus 2, negative number, multiply 5 by 2 by minus 2 and multiply 3 by minus 2. So minus 5 into minus 2 will give us minus 10 and 3 and minus 2 give us minus 6. Now look at these numbers, we get the minus 10 and minus 6. So which is greater, minus 10 is greater or minus 6 is greater? So we know that minus 6 is greater, so this will be like this and equality. Now if you look at after multiplication with the negative number, the inequality has changed. Analogous properties are true if the inequality signs are changed. So mean if we change the inequality sign in the first, okay, if we are taking A, always we took A greater than B. If we take A less than B, so we get the analogous properties of the inequality. And now the next is the absolute value. The absolute value that is represented by in this way, absolute value of a number A represented with two vertical bars. This is called the mod of A. The absolute value of a real number A, of a real number A defined as follows. A magnitude is equal to A if A greater or equal to 0 minus A if A less than 0. So this is the definition of absolute value of a real number A. So examples: so absolute value of 3 is positive, so 3 is positive, so it will give us the same result 3, and minus 3, absolute value of minus 3. If you look at this one, so A is equal to minus 3 now, so by definition this is less than 0, so we take minus 1 outside and take the minus 3. We have used this one, we are using this one, so this is equal to plus 3. So absolute value makes a negative value positive. Now absolute value of 0 will be 0, and absolute value of 3 minus pi, 3 minus pi, pi is, we know that pi is 3.1416, so 3 minus pi is then negative, 3 minus pi is negative number, so minus 3 minus pi, so that will give us 3 minus 3 plus pi. So these are the examples. You can find many more examples in the book or on the internet. You can find so many of examples of absolute value of any real number. And now the properties of absolute value. Properties of absolute values. B greater than 0. So number 1, absolute value of A less than B if and only if minus B less than A less than B. So A, absolute value of A less than B if only if minus B less than A less than B. So number 2, absolute value of A greater than B if and only if either A greater than B or A less than minus B. So number 3 property, absolute value of A is equal to B if and only if A is equal to B, A is equal to minus B. So these are the 3 properties of the absolute values. So be remember this one, we will use these properties to solve the inequalities. And you know very well that what is an equation and what is an inequality. So we have defined so far the inequalities by taking the numbers, and you know the equations. So because we have to solve some inequalities containing x, so before this we must know what is an equation. So we first write the equation, then we define the inequality in x. So an equation in x is a statement is statement such as x square is equal to 3x minus 4 or 5x cube plus 2 sin x minus under root x is equal to 0. So these are the equations, and any inequality in x is a statement that at least one of the symbols less than, greater than, less or equal, or greater or equal, such as 5x minus 4 greater than x square, or minus 3 less or equal to 4x plus 2 less than 5. So these are the inequalities. So if you look at the above statement, the equation that contains equality symbol only, and the inequality that contains, and statement contains inequality symbols, any one of the less than, greater than, less or equal to, or greater or equal to. This symbol is less, this symbol is used for greater than, and this symbol is used for greater or equal to, and this symbol is used for less than or equal to. So I write in front of each one of them. So this is used for less than, this is used for greater than, this is greater or equal to, this is less than or equal to. So these are the 4 inequality symbols which you must remember. And now we come to the intervals, because when we solve these equation, the inequalities, we will write the solutions in the form of intervals. So in the next we will see the symbols for the intervals and the notations, and we will define that which interval is closed, open, infinite or semi-infinite, like this. If you look at the table given, so if you look at the first one, first is interval a b are 2 real numbers, and these small brackets are given. So small brackets means this interval is open from the left hand and open from the right hand. So in set notation we write in this way, x such that a less than x less than b, and geometrically we write in this way, this is a real line. On the real line 2 points a b are known, and in between a and b, all the points in between a and b, they are included in this interval, and this is called a finite interval, and this is open interval. This is finite and this is open interval. This is open at both the ends a and b. And the second interval, this is a big bracket, and this is called the closed interval. In set notation we write x such that a less or equal to x less or equal to b, and geometrically we represent in this way with the solid line including a and b. There is no circle at the end point, like we have seen this, there was a circle at the end. Circle mean the a is not included in the interval, this circle mean b is not included in this interval, but here this is a solid at A and there is a solid at B, so it means A and B are included in this interval. This is finite because A and B are finite numbers, and this is a closed interval. So next third one is, so there is a big bracket on the left side and on the right there is a small bracket, so it means at the left side, so this interval is closed, but from the right side it is open. So we write in this way x such that A less or equal to x and x less than B, and geometrically we represent in this way. Look at the end point A, the interval is closed, so this it is solid, and at the end point B it is open, so this is a circle at B. So this is called a finite and half open. And similarly the next interval is that a small bracket at the left point A and a big bracket at the right end point B. So this interval is closed from the right side and open from the left side. So geometrically it's written like this. There is a circle at the end point A and the solid at the end point B. So this line represent the interval, and this is a half open interval again. And the next interval is in minus infinity B. So at the right point the interval is closed. This is a big bracket. So we write in this way x such that x less or equal to B. So geometrically represented in this way. So all points less than B or equal to B are included in this interval, and this is infinite interval and this is closed. So because at the infinite side we don't say it is open. Minus infinity and B, again the same interval, but on both ends we have a small bracket. So B is a finite number because, so we write x such that x less than B. So if you look geometrically, so at the end point B there is a circle, so mean B is not included in this interval. So this is infinite but open. This is infinite and open. And similarly the interval is A to plus infinity. At the end point A there is a big bracket, so mean it is closed from the left end point. So of course this is a right end point is infinity, it is called closed. So we write x such that x greater or equal to A. So we write in this way geometrically, it is like this. At the end point A it's a solid and it is increasing towards the plus infinity, so infinite and closed. And similarly this is an open interval but infinite, like at the end point A it's open. So we write x such that x greater than A, and you see geometrically at the end point A this is a circle, so mean open at the end point A, so infinite and open. And the last is minus infinity to plus infinity. So this represents the whole real line. So this represents the whole real line. So all the real lines from both ends, it continues from the both ends. It should be here, my arrow should be over there also on the left side. So infinite, open and closed. Now let us solve few inequalities. So example 1. Solve each inequality so A part is minus 5 less or equal to 4 minus 3x over 2 less than 1, and B part is x square minus 10 greater than 3x. Solution. So first write the A part, minus 5 less or equal to 4 minus 3x over 2 less than 1. So first what we should do, we should multiply by 2. So multiplying by 2, so in this way we can eliminate the friction. So multiplying by 2 this inequality, so minus 5 into 2 will become minus 10, and you multiply with this 2, 4 minus 3x less than, but now multiply 1 by 2, you will get 2. So next is eliminating 4 from this, so that we want to separate the x off. So for this what we should do, subtracting 4 from the each part. So minus 10 minus 4 plus 3 plus minus 4 plus 4 minus 3x less than 2 minus 4. You look at this, minus 4 plus 4 will cancel, minus 10 minus 4 will become minus 14, and this 2 minus 4 become minus 2. So this will be minus 14 less or equal to minus 3x less than minus 2. Now dividing by minus 3, because the coefficient of x is minus 3, now dividing by minus 3, so that we get only x in the middle. So dividing by minus 3, because there is a minus symbol, so inequality will change, because the negative sign changes the inequality. So minus 14 divided by minus 3, you will get 14 over 3. This will become greater or equal to minus 3x divided by minus 3, you will get x, and this will be minus 2 divided by minus 3, 2 over 3. So we can write in this way, 2 by 3 less than x less or equal to 14 by 3. So this is a solution in the inequality form. So we write in the interval form, solution in the form of interval. So 2 by 3, because this is x greater than 2 by 3, so at this end the interval will be open, and because x less or equal to 14 by 3, so at this end the interval will be closed. So 14 by 3, and there will be closed interval. So this is half open interval. B part, x square minus 10 greater than 3x, x square minus 10. Okay, subtracting minus 3x from both sides, so this will be cancelled. So we get x square minus 3x minus 10 greater than 0. And how to solve it? Because this is a quadratic expression, so we can factorize this one. You know the how to factorize a quadratic expression. So x square minus, the factor will be minus 5x plus 2x minus 10 greater than 0. So x taking common, x minus 5 plus 2 taking common, x minus 5 greater than 0. So we are left with x minus 5 and x plus 2 greater than 0. So we got the two factors, x minus 5 and x plus 2, their product is greater than 0. So we got x minus 5 into x plus 2 greater than 0. The product of these two factors is positive. So we have to locate at which point these two factors have the same sign, because if the x minus 5 and x plus 2, if both are positive, then their product is positive, or if x minus 5 and x plus 2 both are negative, if both are negative, then their product will be positive. So we have to locate the points where both the factors x minus 5 and x plus 2 both have the same signs, means both are positive or both are negative. So these will be the solution of this inequality. So we locate this one. So let us draw a real line. We draw a real line. Let's say this is straight line. Okay, this is plus infinity, on this side is minus infinity. Okay, somewhere this is a point 0. Okay, we take this x minus 5 factor. So 5 5 becomes 0 at what point? When x equal to 5, x minus 5 becomes 0. So let's say this is a 5 point, this is 5. So at this point, this the x minus 5 becomes 0. This is, let's say, I say this is 5. So at 5, so x minus 5 becomes 0. So if we take any number less than 5, let's say 4. If x is 4, x minus 5 become negative. So if you take any value less than 5, x minus 5 become negative. You please try any value less than 5, like 4, 3, 2. Agar x 1, 2, 3, 4, so we take any value of them, so x minus 5 will be a negative. So we can put the negative symbols, minus, and for x greater than 5, so x minus 5 will give us a positive. So we got the sign for the x minus 5, and now we take the sign for the x plus 2, and now look at this, the factor x plus 2. So x plus 2 become 0 at what point? So if x is minus 2, then x plus 2 become 0. So locate minus 2 somewhere. Let's say this is a minus 2. So minus 2 is somewhere here. So put some dotted lines over here. So minus 2 is somewhere here. If any value less than minus 2, so there will be minus 3, so minus 3. So if you take any value less than minus 2, so x plus 2 factor will be negative. For example, if you take x equal to minus 3, then x plus 2 will be minus 3 plus 2 क्या बनेगा? So that will be a negative. But if you take minus 1, let's say somewhere is minus 1, x is minus 1, so minus, you put minus 1 over here, minus 1 plus 2, minus 1 plus 2, that will give us plus 1. So if any number greater than minus 2, so we get x plus 2 will give us a positive, and negative for any value less than minus 2. Now we look at which point both the factor have the same sign. So between minus 2 and 5, both have opposite sign. Between minus 2 and 5, x minus 5 factor is negative and x plus 2 is positive. So this part of the real line will not be a solution of the inequality, but between minus 2 and minus infinity, both are negative, and between 5 and plus infinity, both are positive. So these will be the solution. So we can write the solution. Solutions are real numbers in minus infinity, minus 2 union 5 to plus infinity. So we will write, there are two intervals, so we write them in the form of union. So all the points in this interval will be solution of this inequality. So it's so simple. A little bit complicated, but it's not difficult. you should try to look at again this example and you will understand the things. Now let's take one more example. Example 2. Solve inequality x minus 3 mod less than 0.5. Now we will use the first properties of the absolute value. So properties of absolute value. So we know that this one, the first property. We will use the first property of the properties of the absolute value. X minus 3 mod less than 0.5. If you remember this absolute value property, A mod less than B, then we write if and only if I double F we read if and only if minus B less than A less than B. Now you locate what is A and what is B in your question. So A is x minus 3 and B is 0.5. So we can write in this way, minus 0.5 less than x minus 3 less than 0.5. Now first we have used the property of absolute value, and now we'll solve this inequality. So what we will do? So adding 3 to both sides, minus 0.5 plus 3 x minus 3 plus 3 less than 0.5 plus 3. So this will give 2.5 less than x less than 3.5. So solutions are real numbers in 2.5, 3.5. So because there is no equal symbol in the inequality, so the interval will be open. This is a solution in the form of interval. Let us take one more example. Example 3. Solve 2x minus 7 greater than 3. So this is the second property of the absolute value. You know this one, A magnitude greater than B if and only if either A greater than B or A less than minus B. So we will use this property to solve this one. So 2x minus 7 mod greater than 3. So we write in this way, 2x minus 7 greater than 3 or 2x minus 7 less than minus 3. So if we solve the first inequality, 2x minus 7, we add plus 7 to both sides, 3 plus 7, so 7 will cancel, 2x greater than 10. Now dividing by 2 both sides, so x is greater than 5. And now we solve this one. For this we use the same thing, adding the plus 7 to both sides, minus 3 plus 7, so plus 7 minus 7 will cancel, and we are left with 2x is less than 4 plus minus 3 plus 7 4. So dividing by 2x, so x less than 2. So we have a solution, all x greater than 5 and all x less than 2. So we write in this way, we write, okay, so how can we write the solution in the form of interval? So draw the real line and locate the points where are 2 and 5, and then we will see from the real lines. Now we have to write the solution in the form of interval, and we can't observe from this that what will be the interval. So we can write the interval if we draw the real line and locate the points 2 and 5 on the real line, and we can see that what will be the solution using this inequality. So draw the real line. This is plus infinity and this is minus infinity. There will be somewhere 0 in between. Let's say this is a point 2, and look at this is point 5. So first look at this, x greater than 5. For x greater than 5 means, so all numbers x from 5 to plus infinity, these are the solutions, and x less than 2, so all numbers less than 2 from 2 to minus infinity, this is the solution. So the points between 2 and 5, they are not part of the solutions. So we can write the solution in the form of, so minus infinity to 2 union 5 to plus infinity. So this is the solution of this inequality. So we have solved some inequalities by using the properties which we have studied, properties of inequality and properties of absolute value of real numbers. You can there will be a number of questions you can find on internet, or you can see the book of calculus written by the Skorsky, the 6th edition. There are many questions in the beginning of the book relating to the inequality. You try to solve. Please apply, go through the book and go through the lectures once again, and do the practice of these exercises and the example, so that you can get master in this lecture or the inequalities. So inshallah we will start the next lecture with the topic function, and that will be I completely follow after then the book of calculus written by the Howard Anton, the 8th edition. So I want to say goodbye at here. So in the lecture number 2 we will start the new topic, the function, and I will follow all this, the book of calculus written by Howard Anton, 8th edition. So till that I want to say you goodbye and Allah Hafiz.